Hi everybody, it's David again here from CD Surveys. What I'm going to do today in this video, which is part 10 of the set, is to show you how the various methods that are used in the field to survey the points of detail, the levels, the stations, the control, with various methods. Trilateration, which is measurement using distances on the triangle. Three-hair stadia, which is using a basic level instrument, automatic level instrument, and taking the bottom hair from the top hair, reading a staff, and multiplying that by 100, which gives you your distance. And then doing it by chain and offset, which is another method, simple method if you get lots of detail. And then proving that detail with a total station instrument, which was bashed, but we managed to get it working. I did some tests on it also. Even though it looks a bit odd, it actually gave us a pretty good result, and we got 0.2 of a millimetre in the easterns and the northerns relating to the loop, the Travis loop that I did. Anyway, so what I'm going to do is, this is the introduction, and what I'm going to do now is I'll show you the various things on my laptop and record that just to show you what I did and how it compares. And then there's a PDF of it with the layers, so that you can switch off and on the layers to see the different methods. And then there's also an AutoCAD drawing if you want to load it and view it. And then I've also done a text document which goes through each part and what the results were. So this is the computer down there, and what I'll do is I'll switch you off, go to the computer and start recording that, and then add this to it. Alright, cheers now, bye bye. Right, hi everyone, it's David Watterson again here from CD Surveys, in regarding the intro that we had about the comparison that we're going to do between the 4 survey methods. The first one being taken from three-hair stadia, then trilateration, then chain and offset, and then approve the whole lot using a total station. But anyway, on the screen here, this is the site, and you've got a gateway here, you can see the mouse, and then electric fence going round the side, a ranging pole over there, which is the corner of our 5 metre level grid, another ranging pole there, which is another corner of the level 5 metre level grid. Then these 2 poles up here is a fictitious fence I've got, and behind that cone, and the other cone over there, and the other cone over there is survey stations. And you can also see the bamboo canes that I've set out, the 5 metre grid, 1, 2, 3 and 4. And again, I've got them coming back here, 1, 2, you can see. And then there's an IC there that was surveyed. Can I zoom in it? Probably not. But anyway, there's an IC there. Yeah, I can zoom in it. No, all right. Anyway, so that was the site. There's the IC there again. And what I did was I surveyed, as I said, with three-hair stadia, and then punched it into our survey processing software, which is the layout you can see here. It's a combination of data that goes in and gets processed in our survey and stuff, and it ends up that you end up with a set of coordinates, which I've got on this screen. So we had the start values that I had used as an origin, an arbitrary origin, 1000 east, 1000 north, and 10 metres in height, and that was the values for station A, B, C and D. Then with the three-hair stadia, I traversed it using the circle at the bottom of the level, took the angles and took the distances with the three-hair stadia, taking the bottom from the top, multiplying it by 100, and you end up with the result. And these are the coordinates that I arrived with through that processing software, and they're all pretty good. I mean, they're certainly acceptable to what you achieve, which is plus or minus 100 mil with the with the 3-year stadia tachyometry. All right. And I put all that together in a text document that's on your handouts, number 46, I think it is. And it says CD surveys, different survey methods analysis. And it shows you the file that we used, and then the notes on the drawing that I'll show you in a minute. And the first task, as I said, was set out a level grid. Then the second task was using an automatic level to take distances and angles using 3-year stadia. Accuracy of that's plus or minus 100 millimeters, due to you being able to read the millimeter on the staff, nothing more than that. And that was the Travis result, which you showed you the coordinates earlier. So I got nearly 100 mil, which was the length of the misclosure. That's the difference east, difference north, and the hypotenuse. And it was acceptable. Third task, then I used chaining offset or taping offset to survey the detail that I showed you. And this is a method of laying out a baseline and then measuring off that exactly at right angles. And you can use a optical square to get the angles, clap your hands together, or swing the tape back and forward to make sure you're 90 degrees from your detail. The fourth task, as I say, you can read this all in detail, was trilateration, which is solution of triangles using distances at either side of the triangle, and that is the best and most accurate way of fixing detail. And then the last and fifth task was to measure it all using a proper instrument that I can rely on, that gives you 1 millimeter in the distance and 1 second in arc, so it was very accurate. And this is the results I got on that, which was 0.2 of a mil east, 0.2 of a mil north, and 0.3 of a mil on the misclosure, and 1 in 200,000. Whereas the 3-year stadia Travis using the level was 1 in 770. So much less, but that's what you expect. And then I put the whole lot on a PDF, and you can zoom in, and in here you've got a layering control, which if you switch off and on the little eye, it will then switch off and on the level that we're observing, which then shows you what I've been looking at. And I've got an example of that. So if you're looking at this and you want to see the fences, if you can see there, the fences pop off and on by switching off and on their line. And the level grid using bamboo canes is in green, and you can see me switching off and on them. So you can go through and look at all that and familiarise yourself with what tasks I use and what results I got. And there is, if I show you in the AutoCAD one, there is the ellipses, the error ellipses around the detail. And I had to use different object names for them so that I could differentiate what I was looking at. But they're all in there. It's all quite obvious. And thank you for your time. And as I say, you can look through the 9 videos which show you what I did with a whole lot of it. And there's a note at the bottom of the PDF that says what the videos are, production 1 to production 9, which I checked the levels with a rotating laser. And spend a bit of time looking at it, because it will give you confidence in being able to do a survey with simple methods. All right? Anyway, thanks for your time, and we'll see you later. Cheers now. Bye-bye.